Hello, you're welcome to this lesson. In this video, we are going to learn how to compute the limits of piecewise functions. Okay, so we have this function f of x, which is equal to x squared plus 5 if x is less than minus 2, and then 1 minus 3x if x is greater than or equal to minus 2. We have to find the limit of f of x as x approaches minus 2. Okay, so let's look at how we are going to do this. Okay, so for limits, we don't focus on the behavior of the function at that particular given point, but we focus on the behavior of the function for values that are very close to the given point. Okay, so let me further explain this to you. So let's say you have a function f of x, okay, and then you are supposed to find the limit of this function f of x as x approaches a certain value a. What we do is that we don't focus on the behavior of this function f of x at the given point a, okay, but we focus on the behavior of this function for values of x that are very close to the given point a from both sides. If I say from both sides, that means that we consider values that are very close to a but smaller than a, and then we consider values that are very close to a but what bigger than a, and then we look at what the behavior of this function when you substitute those values into the function, and then that will give us the limit of the function as what x approaches that particular point. So what we do is that we compute what is known as the left side limit and then the right side limit, okay, and then we look at the values that we get for what those one-sided limits, and then we use that to tell what our limit will be. Okay, so let's say that in this case we compute the left side limit for this function. That will be the limit of f of x, okay, as x approaches a from the left side, which means that you are considering values that are close to a but less than a. Okay, so let's assume that you compute that limit and then we get our answer to be L. Okay, and then we compute the right side limit, okay, also, which means that you are considering x values that are close to a but bigger than a, and then we get that one also to be L. Then that means that the limit of the function as x approaches a will be equal to what? L. Okay, so for us to get the limit of a function, then both the left side limit and then the right side limit must be the same, and then the value that we will get will be the limit of the function as what the x value as the x value approaches that particular given point. Okay, so this is what limits is about. So you are going to use this understanding to solve this question that we have here. So let's go ahead. Okay, so for this question that we have here, what you are going to do is that you are going to compute both the left side limit and then the right side limit. Okay, so for the left side limit, okay, for the left side limit, you are going to have the limit of f of x as x approaches minus 2 from the left side, which means that you are going to consider values that are very close to minus 2 but are less than what minus 2. Okay, so let's look at how you are going to do this. So to compute this limit, you know that this function is a piecewise function, which means that the function has been grouped into parts. Okay, so we've been given that if the x values are less than minus 2, then this will be the part of the function that we are supposed to use. Okay, so let's take note of this, and then we are considering values of x that are very close to 2, sorry, that are very close to minus 2 but are what less than what minus 2. So what that means is that you are going to use this part of the function because the question says that if x is what less than minus 2, then that's the part of the function that we are going to use. Okay, so to find the left side limit, okay, what you are going to do is that you are going to use the function x squared what plus 5. Okay, so you are going to have this to be equal to the limit of x squared plus 5 as x approaches minus 2 from the left side. Okay, and then to compute this limit, you are going to have minus 2 squared plus 5. Okay, and then this will give us an answer of what 9. So that will be the left side limit. Okay, but you can't see that this is the limit of the function as what x approaches what minus 2, because you have to compute the left side limit also, sorry, the right side limit also. So let's compute the right side limit also. So for the right side limit, you're going to have the limit of f of x as x approaches minus 2 from the right side, which means that we are going to consider x values that are close to minus 2 but are what greater than what minus 2. Okay, and then if you look at the function that was given to us, if the x values are greater than or equal to minus 2, then you are supposed to use what this part of the function. And in this case, you are considering x values that are what close to minus 2 but are greater than what minus 2, so that falls within this domain. Okay, so we are going to use what this part of the function. Okay, so this will be equal to the limit of 1 minus what 3x as x approaches minus 2 from the right side. Okay, so we can do the substitution and then see what you are going to get. So if we do the substitution, you're going to have 1 minus 3 into bracket minus 2, and then this will give us a value of 47. So you see that the left side limit is not equal to the right side limit. Okay, so we will say that the limit of this function does not exist. Okay, so that's how we compute for the limit of what piecewise functions. So let's take one more example for a better understanding. Okay, so I have another example here, giving the function f of x equals x squared plus 5 if x is less than minus 2, and then 3 minus 3x if x is greater than or equal to minus 2. Find the limit of f of x as x approaches minus 2. So let's look at how you're going to compute this limit. So you know that you have to compute the left side limit and then the right side limit, and then compare the answers, and then if they are the same, then that value will be the limit of the function. If they are not the same, then that means that the limit of the function does not exist. So let's look at how you are going to do this. So let's compute the left side limit first. So for that one, you're going to have the limit of f of x, and then in this case our f of x would be x squared plus 5, okay, as x approaches minus 2 from the left side. And then in this case you're going to have minus 2 squared plus 5, and then this will give us an answer of what 9. So you're going to compute the right side limit also, where you're going to have the limit of 3 minus 3x as x approaches what minus 2, and then in this case you are going to have 3 minus 3 into bracket minus 2, and then this will also give us an answer of what 9. So you see that both the left side limit and then the right side limit are the same, so the limit of the function as x approaches minus 2 will be equal to what 9. Okay, so this is how to compute the limit of what piecewise functions. Okay, so our main focus will be on the one-sided limit. You compute the left side one-sided limit and then the right side one-sided limit, and then you compare the answers. Okay, if the answers are the same, then that value that the answers were equal to will be the limit of the function. Thank you very much for watching this video.